Hey guys, we're going to talk about the zero product property today. So it's going to help us with our quadratic equations, our parabolas. So first we're going to talk about what do you actually need in order to sketch a parabola. So what if we just have a y-intercept? Is it enough information if we have the point 0, -15 to sketch a parabola? If I have the point 0, -15, can I draw the same parabola that you can draw? Well, I can draw a parabola where that's a vertex. I can draw a parabola where it's the maximum. I can draw a parabola where it's just another point. There are multiple ways to draw a parabola, so one point is not enough. Well, what if we have 2 points? In particular, 2 x-intercepts. So if we know that it crosses the x-axis at 5 and -3, can we sketch the parabola? Well, we're a lot closer. I can make a parabola look like that, but it could also go the other way. So now we're down to 2 different parabolas. So the point that we're missing is telling us what direction we're going with this parabola. So that's when we want to look at the x-intercepts and the y-intercepts together. Because as long as we know an x-intercept of 5 and -3 and a y-intercept of -15, we can make that parabola shape. So how do we find those 3 things? That's what we're talking about today. So first we need to think about what is true for all x-intercepts. Well, x-intercepts are all going to be on our x-axis. Any point along this x-axis is an x-intercept. What do they all have in common? All of their heights are 0. So all x-intercepts have a y value of 0. The opposite is true for all y-intercepts. Y-intercepts are on our y-axis, and all of those have an x value of 0. So how can we use those ideas to find the intercepts of the parabola y equals 2x squared plus 5x minus 12? Well, to find the x-intercept, we can plug in 0 for y. To find the y-intercept, we can plug in 0 for x. So let's do that. Let's find the y-intercept first. So we're plugging in 0 for x. And when we do that, if you notice, everything cancels out except for the constant. So when x is 0, y is -12. Now we can find the x-intercept by setting y equal to 0. This is where we run into a problem right now. Because we have an x term and an x squared term, we can't just solve for x. We can't get x by itself. So in order to find these x-intercepts, we're going to have to take a side step and talk about something called the zero product property. So basically, if we have two numbers and you multiply them together and get an answer of 0, what can we assume? So if I take two numbers, multiply them together to be 0, that tells you that one of the numbers has to be 0 because that's the only way we can get 0. If we take three numbers and multiply them together and say that the answer is 0, again, in order to get an answer of 0 with multiplication, one of those numbers has to be 0. And does it matter how many numbers are multiplied if the product is 0? What do we know about one of them? One of them has to be 0, because in multiplication, that's the only way to get 0. So, the first thing that we need to do is be able to get something in multiplication. So right here, I wrote our quadratic as a sum. Well, our product is multiplication. So we can use our generic rectangle and our diamond to rewrite this as a product. So we're going to plug in our x squared and our constant, multiply those two together, and then put in our x's. So what multiplies to be negative 24 but adds to be 5? Well, that's going to be an 8x and a negative 3x. Plug those into our rectangle and find the outsides. So we can rewrite this sum, 2x squared plus 5x minus 12 equals 0, as our product. We're just going to rewrite the outside. And as you can see, we have two things that multiply to be 0. Well, the 0 product property tells us if we have two things that multiply to be 0, one of them has to be 0. So what we can do is set them both equal to 0 because we don't know which one is actually 0. So we assume they both are. And what we can do is solve for x. And because we set y equal to 0 and solved for x, these are our x-intercepts. Negative 4 and 1.5 is where our line is going to cross the x-axis. So let's look at a problem from start to finish. And we're going to use it to help us make a sketch of our parabola. So I'm going to start by finding the y-intercept by plugging in 0 for x. So we have a y-intercept of negative 8. Now I'm going to get the x-intercept by plugging in 0 for y. So I have a sum equal to 0, which doesn't help me. So we need to use our generic rectangle and our diamond to help us rewrite this sum as a product. So we have a negative 4x and a 2x. And then we can fill out the outside. And now we're going to take this sum up here and change it into our new product. And because we have two numbers that multiply to be 0, that means one of them has to be 0, so we set them both equal to 0. And solve them each for x. And now that we've done that, we can sketch our parabola. So we're going to plot our points, our y-intercept at -8, our x-intercept at -2 and 4. But before we go connecting our points, we first need to find something unique about a parabola. What we need to find is the line of symmetry. We need to figure out where the parabola is going to fold in half. So we do that by finding the middle of our x-intercepts. So if we add the two x's together and divide it in half, that's going to tell us where on the x-axis our line of symmetry is. So our line of symmetry is at 1. And how this helps us, because it's a parabola, everything has to be the same on both sides. So if you look at our x-intercepts, we have 1, 2, 3 away, 1, 2, 3 away. So we can take our y-intercept, 1, 1. And we can add another point. This line of symmetry also helps us find a very important point. It's called our vertex. It's the highest or the lowest point. So once we figure out where our line of symmetry is, where on the x-axis, that represents our x value. So if we take our original equation and substitute in our x where our line of symmetry is, that's going to tell us where on our line of symmetry our point falls. So on our line of symmetry, our point is at -9. And with all of those points, we have a pretty good idea of what our parabola looks like. So why don't you give it a try in your homework and let me know if you have any questions.